problem number 15, we're given a function where we have an inverse trig function. So this is the first one we've encountered like this on this review, where we're taking the arctangent, or the tan. Remember, tan to the -1 power does not mean the reciprocal of tangent. It means the arctangent, or the inverse function, of 3x squared. And our first question is to find the slope of the normal line. So there's a piece of vocabulary there that if you're not familiar with, I'm going to explain that. The normal line is perpendicular to the tangent line. So essentially this problem is saying find the slope of the tangent line at x equals 1 and then find what is perpendicular to that. So in order to find the slope of the tangent line, we need to take the derivative. So taking the derivative of an arc trig function is going to require just knowing your basic derivatives. So the derivative, if we just had arc tan of x, would be 1 over 1 plus x squared. That's something you're just going to need to memorize. But in this case, we're taking it not of x, but of 3x squared. So that means we're going to need to use the chain rule. So our derivative is going to look like that form. It's going to be 1 over 1 plus. Now instead of x squared, it's going to be whatever we're taking the arctangent of squared, which is 3x squared squared. But then because of the chain rule, we have to multiply by the derivative of the inside, just like we would have to in any other type of function. So the derivative of 3x squared, the inside, is 6x. So we have to multiply by that because of the chain rule. So therefore, in a more simplified form, our derivative becomes 6x on the numerator. And the denominator, 3x squared squared, is 9x to the fourth. So there's our derivative, 6x divided by 1 plus 9x to the fourth. So we're asked to find the slope of the normal line at x equals 1. So let's first find the slope of the tangent line, which is just when we plug in 1 here. So if we plug in 1 to the derivative, we would get 6 over 1 plus 9. So 6 over 10, which simplifies to 3/5. So the slope of our tangent line at x equals 1 is just 3/5. But we want the slope of the normal line, which has to be perpendicular to that. So the slope, I'll put m norm at the bottom. So the slope of our normal line is the opposite reciprocal of that, which is -5 over 3. So that's part A. And then for part B, we're asked what's the second derivative of this at 0. So I forgot f prime of x here. So now to answer part B, let's take the second derivative. So now we need to take the derivative of this. So f double prime here would be the derivative of this function. And for this, we need to use the quotient rule because we have a fraction where both things are not easily simplifiable. So remember that to do the quotient rule, we need to memorize that formula. So we do the derivative of the top, which would be 6 times the bottom, minus the derivative of the bottom times the top. So the derivative of the bottom would be 0 here for the 1. This would be 4 times 9, 36x cubed, times the top, which is 6x. All divided by the bottom squared. So 1 plus 9x to the fourth squared. So that's our quotient rule. Now you might think that looks really nasty and it's going to be hard to simplify. You're right, it is really nasty and it's going to be hard to simplify. But the thing is we don't need to, because what this question asked us is just what's f double prime of 0. We can plug in 0 for x here without simplifying that, and in this case that's what we want to do. So when we plug in 0 for x, this goes away because that's 0. This whole term goes away because x is 0, and this goes away. So really we just get 6 times 1, 6 minus 0. And on our denominator we get 1 plus 0, 1 squared, which is still 1. 6 over 1, which is 6. So that's one thing you can keep in mind if you have this kind of question on a test. if you're asked to evaluate a derivative or a second derivative or something and plugging in a value, you can do that without simplifying the equation, and sometimes that will be faster and simpler. And this was a good example of that.
The Teaching Center, UF's Learning Resource Center.